What we have here is a Colpitts RF oscillator. We have connected 15 volts power supply to the VCC of this module, and we have connected the ground return for the power supply through the black banana connector. As you can see, this power supply goes to the power supply we have kept there. We have got two other variable voltages, V1 and V2. These V1 and V2 supply varying voltages to the varactor diodes in the oscillator. This V2, on increasing the voltage of the V2, the capacitance of the varactor diode is decreased, which results in increased feedback to the emitter of the transistor. If we increase this V1 voltage, this decreases the capacitance of the diode D2 and the resonant frequency of the tank circuit is changed. In fact, a combination of V1 and V2 can be used to change the center frequency and RF power output of the Colpitts RF oscillator. This is a very common RF oscillator used in a number of circuits. And now you see, if I increase this V2 voltage, as we can see, the RF output of this module we have connected to the spectrum analyzer. As we can see, what we see here is the fundamental waveform. This is the second harmonic and this is the third harmonic of the waveform of the Colpitts RF oscillator. As we can see, this fundamental level is roughly about 110 dB microvolts, or about plus 3 dBm, or about 2 milliwatts, while the level of the second harmonic is roughly 14 dB below the fundamental, and the level of the third harmonic is roughly about 24 dB below the fundamental. We can reduce the feedback in the oscillator to decrease the level of the harmonics. The center frequency right now is roughly, as we can see, it's roughly 135 megahertz. Now if we change the V2 voltage of the module, we see that the frequency changes. It increases in frequency, while at the same time the level of the second and third harmonics goes down slightly. It could be because of the change in the feedback due to the change in the capacitances. Now if we change this voltage V1, while the V2 voltage is at roughly about 12 volts, we see that the frequency is further increased from 150 and it goes up to roughly about 175 megahertz. Right now both V1 and V2 voltages are at 12 volts. We can take a plot of the frequencies in relation to the voltages of V1 and V2, and we can find out the several characteristics of the module as to how the frequency is behaving in response to the change in the voltages. Now if we reduce the V2 voltage while V1 voltage is kept high, we can see that instead of the change in frequency, the level of the second harmonic is reducing. This is because the tank frequency is remained same, while the feedback capacitance is reducing, which is changing the Q of the oscillator, and the level of the second harmonic is going down. So as you can see, if I reduce this capacitance, I am able to change the levels of the second harmonics. So we can perform several experiments on this RF oscillator. The behavior of the oscillator in response to the change in the supply frequency, in change to the supply voltage. If the supply voltage is reduced or increased, what is the change in the frequency? So how much is the frequency pulling?